This video is on graphing radical functions. I'm going to do two examples of graphing a square root function that is not just translations. We're going to be focusing on the entire transformations that are happening. So example 5, this is graph y equals 2 square root of x plus 3, then minus 1. So since it is a square root, we do have a start point. And our start point still comes from our h and our k. So our h value is from inside the radical, h is inside the radical. What will make the inside equal to 0? So we want negative 3 plus 3 gives us 0. So the h value is actually negative 3, comma. And then our k value is what's added or subtracted to the outside, which is negative 1. So again, this is our start point. So we do put negative 3, negative 1 as our first coordinate. Then we want to go find other coordinates by using our calculator. So if we go to our calculator, our y equals, we type this in as 2 square root of x plus 3. And we have to make sure we get out of the radical or make sure you close it. So if I use an older calculator, if I go to my y equals, older calculator, I put 2 square root of x plus 3, but to get out of my radical here, I have to close the parentheses, and then I can type in minus 1. So these will give us the same thing. I just have to make sure that I know which type of calculator I have. So if I press my graph here, and then if I press my graph on this one, I get the same graphs. So these are actually the same two graphs, so that means that I did graph them correctly and I typed it in correctly. So we have our graph. We can see that it's starting here, which is at that negative 3, negative 1. And then there's nothing over on this side or down below, which is perfectly fine because it's a radical. So if I go to my second table, my table, I need to start at negative 3, negative 1. And if we can see all the ones above that will be errors, because we're not allowed to have the square root of a negative. So the next good coordinate that we'll be able to graph is negative 2, positive 1. So negative 2, positive 1. Then the next one that is good to graph would be 1, 3. So positive 1, positive 3. The next one that would be good to graph would be 6, 5. We try and stay away from the decimals if possible. If there are no other ones that we can graph, then we would graph the decimals. Especially if there are decent decimals like half, then we can try and graph those. So 13, 7 would be the next one, but we can't graph that on this grid because it only goes to 7. So if we graph these, our start point is negative 3, negative 1. Then we have negative 2, positive 1. Then we have positive 1, positive 3. Then we have positive 6, positive 5. We connect these points. Remember, this is your start point, so nothing goes below it, and there's no arrow on it. So we connect these. We put arrow on the end of this side. Now this one is different than the ones in the previous graph. It's actually steeper because it's actually multiplied by 2, and that's one of the reasons why we went up by more than just 1 on that first from start point to the second point. So if we're talking about our domain and range still come from our h and k value because it doesn't go left and right forever. It starts with the domain is negative 3, and it does go right forever, so that will be a positive infinity. So we want the negative 3 and then a positive infinity. Close bracket on negative 3, open bracket on infinity. For our range, comes from our k value, and this graph is going up forever, so that means that we do want a positive infinity. So we do want a negative 1, then our positive infinity. So remember, positive infinity always has to be on the right-hand side. Negative infinity always would have to be on the left-hand side, but this does not have a negative infinity. So to talk about our transformations, again, we want to come from the parent function since it was a square root of x. Our a value is positive. Our a value is 2. Our h value was a negative 3, and our k value was a negative 1. So we got to figure out what changes. Positive, positive does not change. 1 to 2 does change. So we got to talk about this one. 0 to -3 does change. 0 to -1 does change. So these are the three things we have to talk about. So since it is A is a 2, that is a vertical stretch of 2. Since we have a coordinate of -3, -1, from 0, 0, we went left 3 and then down 1. So again, just think of this as a coordinate from 0, 0 to -3, -1. How would you get there? Left 3 and then down 1. That would be your transformations. So again, it comes from the parent function. This was a positive, a 1, 0, and 0. So positive 2, -3, -1. So these three did change. For this last one on square roots, again, we're going to look for our key or start point. Since it is a square root, we will have a start point. So our h value is what will make the inside of the radical 0, which is 1 minus 1, so 1 would make it 0, comma. The k value is what is added or subtracted to the outside, which is that positive 4. So our k value is positive 4. Since that's our start point, we would put 1, 4. Now we're going to go find the other coordinates. So we want to clear this out. We're going to put -1 divided by 2. Actually, I'm going to put that in parentheses. -1 divided by 2, close parentheses. Then I'll put my square root symbol. I want my entire x minus 1 inside the radical. Then I need to get out of the radical. Then I put the plus 4. Now if I press graph, we can see actually this is different. This one is, instead of going up, this one's actually going down. And you can see that this one is now negative in the front, which actually tells us why that's going down instead. So if we go get our coordinates, we're going to go to second table, so go to our table. We know we have to start at 1, 4, so I'm going to scroll up to 1, 4. All the other ones are errors. The next good coordinate is, technically this is 3.5. This one is an okay one to graph. So 2 and 3.5 would be perfectly fine. And the reason why we're actually going to be going by halves this time, if you see in the front, we're multiplying it by half. So we know we're going to end up having decimals. So we want to find the next good one is 5, 3. Let's see if we can find another good one, which would be 10, 2.5. So we won't be able to graph that one, but it's still a good coordinate that we can write. So if we go and graph this, 1, 4 is our first coordinate, then 2, 3.5, and then 5, 3. Trying as best as possible to get it on there. And the next one would be 10, 2.5, which would be over here. So we still have our start point. Remember, there's no arrow on here. We connect these other coordinates. We put an arrow on that one, on this side. So now to talk about our domain. So domain is still our h value. We have a 1. Is going right forever, so it's still going to be a positive infinity. So we're going to have a 1 and then a positive infinity. So a closed bracket on 1, open on infinity. Our range comes from our k value of 4, and then this graph is going to be going down forever, so that's actually a negative infinity. So instead of the 4 first, we have to write the negative infinity first, and then we'll write our 4. Because remember, the infinities tell you which ones have to go first. So negative infinity is always first, positive infinity is always second. So be careful on that. The transformations come again from our y equals just the parent function of the square root of x. Our a value is a negative. Our a value is a 1/2. Our h value is a 1, and our k value is a 4. So remember, the original is supposed to be a positive 1, 0, 0. So positive to a negative, we have to talk about this one. So I'm going to put a little dot beside it. We have to talk about this one. From a 1 to a 1/2, we have to talk about that one. From a 0 to a 1, we have to talk about that. From a 0 to a 4, we have to talk about. So we actually have 4 transformations that are occurring here. So the first transformation is from a positive to a negative. That is reflecting over the x-axis. They reflect over the x-axis. The next one is a 1/2, from a 1 to a 1/2. That is a vertical compress. This could also be called a vertical shrink. So if you ever hear the word shrink, it's the same thing. Vertical compress of 1/2. Then we have the coordinate 1, 4. So to get from 0, 0 to 1, 4, which is how do we get there? So from 0, 0 to 1, 4, we go right 1 and then up 4. That's the other part of your transformation. Right 1 and then up 4. So this is still a square root function. So that's why our domain and range are very specific here, because it is a square root function. But this is when it's more than just translating. You have stretching, compressing, you also have reflecting. So it's imperative that you know your A, H, and K, just like if we were doing function notation.